Good afternoon.
Good afternoon.
All right, well, I can't tell you how happy I am to see all four of you girls here because St. John's is having internet problems. So if one of you would have been sick today or something, then anyway, I shiver to think. But we might have had to blow off class today. So anyway, I'm glad you're here. So St. John's, you'll be watching this video later. So anyway, they're going to try to make it available to them as soon as possible. But St. John's was out this morning. Joseph City's internet was out. So I think both Cable One and Frontier are having issues today. I'm not sure what's going on. Have you guys had any internet problems at Mogollon or Winslow?
Yeah, our school internet's been out like all day. I don't know actually how
Is
it
it
is, but
is it been out or just like slow?
oh, maybe it's just slow. I don't know.
Yeah, see, anyway, there was some issues with so even at home, my internet has been was super slow this afternoon. So anyway, but this is supposed to be on a special line, so it's like transmitted to the schools, but then the local internet line actually makes the final connection. So when the school's internet is out, it does kind of mess up the classes. So anyway, all right. Well, so we've got Mogollon, you guys took the test this morning. Winslow, you guys have not taken the test, right? Any issues with the test this morning? Jordan or Hannah?
So towards the end of my test, it was weird because it froze, but I could still input answers. So I filled everything out and tried to submit it, and I had
Did it
time
submit?
left. It didn't submit, and it didn't even register my last 4 answers, I think. And so it's just frozen, and then I tried to fix that, and it's sitting unsubmitted right now in Moodle. So
Is it like you took it in the library or something?
I took it in the library. I was on the computer out here.
On laptop. So there obviously there's some issues there with it to submit. So, but probably you didn't. I mean, if I were you, I wouldn't have started the second attempt. Right?
I didn't start the second attempt.
Right, that's what I'm saying. I wouldn't have started the second attempt if you didn't know what your score was, or even if the first 4 were submitted, or the last 4. So, all right. How about you, Hannah?
Mine was good. It submitted, but I submitted it earlier, but I only got through 1 attempt.
Right. Okay.
So I'll need to do the second one sometime.
All right. Well, we'll figure it out. Or you guys can be figuring it out once Jordan's got hers graded. So I actually did have. I'm not trying to put pressure on you guys by comparing you always to my homework class, but I did have 2 of my students got 100 on this test. So hopefully, but neither one of them got it on their first attempt. Okay, so they were like saying that there were just a couple of them, but anyway, they were so happy though that I gave the highest score instead of the average like last semester. So anyway, all right. Well, let's go ahead and get started. We're on part 6 on 8.1 on separating a fraction. And so I was going to do this example and then have you try one of these. So again, we're in 8.1, we're just kind of reviewing different, mostly algebra tricks to do integrals. This one, okay, so let me just tell you how my brain works. Like if these words separating a fraction weren't up here, if I didn't know that's what I have to do, I wouldn't think of that first. My first thought is to do like a u substitution. But see, if I pick 1 minus x squared to be u, then negative 2x would be my du, negative 2x dx. And see, I've got this extra plus 2 term. So that messes that up. Okay, then the second thing I would think would be, okay, I have the square root of a squared minus x squared. And maybe I can get that to be like an inverse sine or something. Or, I would start thinking of along those lines. Maybe look up those formulas. But then, see, this just is supposed to be like du up here. See, there's extra junk up there that we don't need. So then that's when I start thinking, okay, if there's extra stuff, then maybe separating the fraction. Okay? Now remember the rule, the algebra rule for separating a fraction is you never can separate the denominator. Well, not never, but you don't separate the denominator, but you can separate each term in the numerator over the denominator. Okay? And integrate those separately. Okay, well, so now this is a u substitution, and this is an inverse sine. Okay? Because so here, if I let this be what's in the underneath the radical be u, then du negative 2x dx. Well, okay, so I need a negative 2 up there, so I pull the 3 out front and multiply by negative 2 and divide by negative 2 to compensate for that. And then this term then just becomes negative 3 halves. Here, let's put the negative up top. So negative 3 halves times u to the negative 1 half du. So then I use the anti-power rule. So add 1 to that exponent, divide by that new exponent, which is the same as multiplying by negative 2. No. Add 1 and get 1 half. Dividing by a half is the same as multiplying by 2. So now these 2's are going to cancel. So I get negative 3 times u, which is 1 minus x squared to the 1 half. All right, now with this one, let's go back. So the second one, I bring the 2 in front, and then that's inverse sine. So it's plus 2 inverse sine of x, and then I just put 1c there at the end. Okay, so when I tried to do the inverse trig or u substitution before, I had too much stuff. I had extra stuff. So by separating it, it makes it work. Okay? All right, so go ahead and try practice 6. All right, so Skylar, when you've got it. Or if you get stuck, let me know.
Yeah, I'm stuck.
Okay. So here, if we separate the fraction, then we get cosine x over cosine x dx plus sine x over cosine x. Okay, now cosine over cosine, that's just 1. So the integral of 1 is just x. And then sine over cosine, that's tangent. Actually, you don't need to do, if the integral of tangent is going to be the minus natural log of the absolute value of cosine. So that one, the integral of tangent, we did that in in chapter 7. And I know you wrote it down somewhere there, but the integral of tangent is one that you either memorize or write it down someplace that you can find it. Okay? All right, so, and then you plug in the limits of integration. So you plug in pi halves minus 0 minus, oh, okay. So the cosine of pi halves is 0. Cosine of 0 is 1. Let's see. Oh, okay, let's see. Oh, this should be, okay, the signs are what's messing me up here. Okay, so this has a minus. So this is minus natural log of 0, and then minus a minus natural log of 1, so that should be plus. But the natural log of 1 is 0, so you get pi halves minus 0 plus 0, pi halves. But this part right here, the natural log of 0 is actually undefined. Okay? And so this then is what's called an improper integral, where when we plug in one of the limits of integration, it actually goes to infinity. Okay? And so we're going to learn how to do those later in this chapter. But so for right now, you just say, okay, this part's undefined, this part's 0, this is 0, so pi halves. Okay? But your calculator actually, most of our limits of integration, I say, oh, just plug it into the calculator. Okay? This one probably wouldn't, it'd probably give you an error. Okay? All right, any questions on that one? Okay, what to substitute is not always clear. Sometimes we proceed by trial and error. Okay? And so when we're doing the substitutions, so we can either use we've got U substitutions, completing the square, whatever. But I don't want you to forget that you can put these in the calculator. So for practice 7, just want you to put that in your calculator and work it out. All right, so Skylar, when you've got it.
Wait, are we supposed to be in radian or degree mode for this?
Always be in radian mode
Oh, so it's oh.
in these.
Okay, 0.707.
0.707. Okay. All right, so everybody feel good about that? Whoops. Any questions on putting it in the calculator? Okay. All right. Well, that's it for 8.1. So any questions on that? Now, if I could offer you a piece of advice on studying for the 8.1 quiz, which will not be until next Wednesday, okay? Don't wait until 15 minutes before the quiz and say, oh, I need to review some of these. The homework or the practice problem, there's a lot in this section. And so if you're gonna probably really feel comfortable at doing these, probably 2 or 3 hours just for this section. So that would be a word to the wise would be start practicing early. Don't wait until even the night before to practice these on 8.1. Okay. All right. So, all right. The next section on this is called integration by parts. And so this is the next technique of integration. This is not review at all. This is all brand new for everybody. Okay? So let me kind of set it up here for a little bit before we get into the notes here. Okay? Do you remember when we did derivatives? If you had two functions, u times v. Okay, if we needed the derivative, could we do u prime times v prime? Could we do the derivative of each one separately and just multiply it together? No. That instead, what we had to do is come up with the product rule. So the product rule was uv prime plus u prime v. Okay, you might remember that from Calc 1. Okay, and so the product rule, we needed a product rule because the derivative of a product was not the product of the derivatives. We had to learn to do this rule. Well, so now when we're doing antiderivatives, the same thing is true. If we do the integral of u times v, it's not the integral of u times the integral of v. So you cannot, if you have x squared times cosine x, you can't do the integral of x squared and the integral of cosine x and multiply those together and get the answer. It would be nice, but no, it doesn't work. Okay? Now, so let me give you an example, just to prove to you it doesn't work. Okay, again, you don't need to write this down or anything, but so we know that the integral of x is x squared over 2 plus c. All right, we know that the integral of x squared, then, see, the idea is that, look, if I could break x squared to x times x, then this integral would be that, this integral would be that, and then we can multiply that, get together. But that doesn't work. See, the integral of x squared is x cubed over 3 plus c. So you can't do it. You can't separate it like that. It doesn't work. There's no product rule like that. And so when we have two functions that are multiplied together, like here we have x e to the x or x cosine x, then we have to do this method that I'm going to teach you today called integration by parts. Okay? All right. So again, you don't need to write this down just yet. But let me just kind of show you where I'm gonna derive the formula for you, show you where the formula comes from. Now, when we get to the bottom line, then that's what you're gonna need to know. All right, so remember, this is the product rule, okay? The derivative of u times v, let me even write that down. This is the product rule. Okay, for derivatives. So the derivative of u times v is uv prime plus u prime v. Okay, that's the product rule. All right, now, if I take the integral of both sides of that equation, all right, then I get the integral of a derivative, so that just sort of undoes it. So we just get u times v. Over here, we get the integral of uv prime plus u prime v, and I can separate those two integrals. Okay? And so now, if I subtract the integral of u prime v from each side, then I get that. And this actually is what I'm going to use for integration by parts. So the integral of, so when we say the product of two functions, then it's u times dv. So we say the integral of u dv is u times v minus the integral of v du. Okay? So that's what I'm going to want you to write down. So let me put it up there. Okay? So I like it in this form right here. So the integral of u dv is equal to u times v minus the integral of v du. All right? So let me show you how this works. Okay? So just watch this one. All right, so let's say if I have the integral of x cosine x dx. All right, so I pick one of these functions to be u and one of them to be dv. All right, so let's say I pick u to be x and dv to be cosine x dx. All right, so the one I select to be u, I take the derivative of. The one I select to be dv, I do take the integral of. All right, so du, the derivative of u, the derivative of x is just 1 dx. For dv, the integral of cosine x dx is just sine x. Okay, now I apply the formula. Okay, so u times v, so that's x times sine x minus the integral of v du. So sine x dx. And so then this integral, I need to do that. So the integral of sine x is negative cosine x. I put a c at the end, and that's my answer. Okay? So that's using the integration by parts. All right, so for practice 1a, I said let u be sine x. So then what would dv be?
X dx.
X dx. Okay, so go ahead and try that. So go ahead and try practice 1A. Okay, so here, so if I let u be sine x, okay, and then dv is x dx. So then the derivative of sine is cosine x dx, and then the integral of x is x squared over 2. Okay? So now you apply the formula. And you say, okay, so it's u times v, so sine x times x squared over 2 minus the integral of v du. So that would be minus the integral of x squared over 2 times cosine x dx plus c. Okay, now, what do you notice about this integral compared to where we started, the integral we started with?
You're just multiplying again.
You're multiplying again, so, but here's the thing, is this integral, see, this is a trig function, this is a trig function, this integral is x, this one is x squared over 2. This one is actually more complicated, okay? So when you're doing integration by parts, if the integral that you get is more complicated than you started with, stop, okay? Just stop right there. And so what we're going to do is change up what we pick for u and dv, okay? All right, so the choice of the u often determines the level of difficulty. All right, so now I want you to try, this is the same problem as practice 1A, only now we're going to let u be x and see if you can, if it flows a little easier. All right, so Hannah, when you've got it.
Okay, I got x cosine x plus sine x
Plus C.
plus c.
Yep, that's it. Oh, did you get negative x cosine x?
Yeah, sorry, I meant to say that.
Okay. So negative x cosine x, and then minus a negative, so that will become plus sine x, and then plus c. All right? So good job. Any questions on that one? All right, so the goal of integration by parts is to go from an integral you don't see how to evaluate to one you can. All right, so believe it or not, we have actually never integrated the natural log function. We've never done that. All right, so today's the day. So we're going to integrate natural log, and we're going to do it. The reason why we haven't done it before is because it requires integration by parts. Okay. Now you might say, well, wait, there's only one function up here. But see, the thing is that natural log, we don't know how to integrate it, but we do know how to take its derivative. So what's the derivative of natural log of x?
1 divided by x.
That's right. So what we do is we pick u to be natural log of x and dv just to be dx, what's left. All right, then we'll say, okay, the derivative of u, we said was 1 over natural log of x, 1 over x dx. And then the integral of dv, the integral of dx is just x. So now we apply the rule. So u times v, so natural log of x times x minus the integral of v du. So minus the integral of vx times 1 over x dx. Well, the x's there are going to cancel. So I just have the integral of 1, which is just x. So it's x natural log of x minus x plus c. All right, now I would recommend that you write that result down. So the integral of natural log, that you have that in your notes so that if you ever need it, you have it. So the original problem, integral of natural log of x, and this highlighted is the answer. So you could use that as a formula. All right, so go ahead and try practice 2. All right, so Hannah, back to you when you've got it.
Okay, I got 5 times the natural log of x minus 5x.
Plus C.
Plus c, I always forget that.
Don't forget the C. Just remember, without the C, a seahorse would just be a regular horse. Okay?
Never thought of that before.
All right. Any questions on that?
What did you put for U and V?
Now, you could have also, look, this is just 5 times the natural log of x. You could have pulled the 5 out front, and then it's just 5 times the last problem. Right? So you could have done it that way too, but I let u be 5 natural log of x, and dv is dx. Okay. All right, any other questions on that? Okay. All right, sometimes we have to use integration by parts more than once. So we'll work it
Mr.
out.
Shaw?
Yes.
So they're doing a robotics send-off right now.
Okay.
So could we go to that, or would you prefer us stay?
So both of you are
Yeah.
okay. All right. Well, I'll make a deal with you. Okay. If you guys, in addition to everything else you're going to do, if you will do some of these problems from 8-2, integration by parts, from the book, then we'll just call it for the day. But I just want you to practice a couple of them before tomorrow. Will you do that?
Yep.
Definitely.
All right. And girls in Winslow, you want to do that or keep going?
We can do that.
Okay. All right. So we'll just stop right here, and then just a couple of them. Okay. Just practice a couple of them, the problems from the book. You guys have a great robotics time, and we'll see you guys tomorrow. Okay.
Thank you.
You bet. We'll see you.